In this unit, what we're going to look at is we're going to look at everything that we can think of when it comes to circles. Now, geometry is all about shapes and their measurements and congruencies and proofs and whatnot. And the circles is one of the staples within geometry. So we're going to take a look at all about circles and in relation to just the basics when it comes to circles today. So we all know circle as a round object, perfect circle, 360 degrees. But what is it primarily composed of when we draw all these lines through it? So what we are going to look at specifically today in terms of definitions and angle measurements regarding circles, arcs, angles, and chords. So basically, a circle is a set of all points in a plane equidistant from a given point known as the center. So here we have circle C. C is the center, and every point around this center C is the same distance from C to that point. So the distance from C to point A is the same as the distance from C to point B, C to D, C to E, C to F. They're all the same measure. So if I give you two circles, how do I know if they're congruent, meaning they are exactly the same size? Well, if they have congruent radii, then they are congruent. So if I take a look at circle G, circle J, I can say GH is congruent to JK. Therefore, this circle G is congruent to circle J. Also, we have concentric circles. Basically, it means a circle within a circle. And here we have a circle A, B, and then on the outside we have circle AC. They are concentric because both circles share center A. Now, a central angle is an angle whose vertex is the center of the circle. So, and its sides contain two radii. So, what this means is if I draw a radius BA and radius BC, what I have created is a central angle. And that measures whatever it tells us it happens to be. Now, conversely, I can say the outside is also a central angle. So we will have actually two central angles due to the fact that I have two angles created here. More often than not, we're going to be talking about the angle created by ABC. Now the sum of the central angles of a circle with no interior points in common is 360 degrees. So what this means here would be angle 1 plus angle 2 plus angle 3 is going to give me 360 degrees. So we can use this knowledge and given information of a circle in order to find out what's missing, like we have here with these three examples. We have to find the value of x. So we're told we have an angle of 130 degrees, angle x, and then the little symbol for right angle. And again, a right angle is always going to be 90 degrees. So we have 130, 90, and x. So if I were to add these three angles, I'm going to get 360 degrees. So to figure out what x is equal to, I have to subtract 130 and 190 from each side. So I'm going to subtract 130 minus 90, and then we can use the calculator if we want to. So 360 minus 130 minus 90. So x is going to be 140 degrees. And we could do the same thing with circle B here. I have angles of 165, 145, and x. So again, we know it's 360 degrees. So if I add 165 and 145 and x, I'm going to get 360 degrees. And I have to subtract the 165 and the 145 from both sides. And when we do that, we're left with x equals, and then again, save time, 360 minus 165 minus 145. So x is going to be 50 degrees in our case here. And then letter C, this time we have 4 different angles. We have 40, 85, x, and the right angle. So right angle means 90 degrees. So for this one, we have 40 plus 85 plus x plus 90 gives me 360. So I can add, on this side, on these two problems, we subtracted everything. So we could also combine like terms. We can add the solid numbers. 40 and 80 make 125. And we add the 90, so we have 215. So we really have 215 plus x gives me 360. So we'll subtract 215 from both sides. So when we subtract 215, we get a 145-degree angle. So that is pretty simply finding missing measure within a circle. Circles, the interior angles add up to 360. As long as I know everything but one, I can find the missing piece. Now what an arc is a portion of the circle itself defined by two endpoints. So if I take a look at the circle Q, we took a look at interior angles. In our previous problems, the interior angle would be angle PQR. The arc is the part of the circle that is comprised of the points between point P and R on the circle. So notice in red, P to R, that would be arc PR. On the blue side, it's also arc PR, only it's a little bit bigger. Typically what they end up doing is they add another point on the circle so you can designate between a smaller arc and a bigger arc. So P, QR, ordinarily be P, and probably S. So we could say the smaller arc would be arc PR, and the larger arc would be arc PSR. So that way there we don't confuse which one is which. Technically, the way the circle was drawn here, they are both arc PR. They're going to have different measures. Now, the central angle separates the circle into two arcs with measures related to the central angle. So the minor arc is the shorter one. So in this case, the red, P to R, would have been the minor arc. So in this case, arc AB would be the minor arc. The major arc is the longer of the two arcs connecting two endpoints on a circle. And notice they added point D here. So we would say it's arc ADB. That way there we have the right notation. Now a semicircle is an arc that has endpoints that lie on a diameter. So diameter is the line segment that runs from one point on a circle through the midpoint to the other side of the circle. It's a straight line. Arc, a semicircle arc is always going to be, in this case, ADB because of the point D there on the semicircle. Now the measure of an arc, how are we supposed to figure out what the measure of an arc is? Well, the measure of the arc is equal to the measure of the central angle. So given circle Q here, minor arc PR, and a central angle PQR, if angle PQR is 120, then the measure of the arc PR is also 120. It's not necessarily 120 degrees, it's just 120. So let's put that into practice. We have GJ is a diameter circle K. Identify each arc as a major arc, minor arc, or semicircle, then find its measure. So first thing, we have to find GH. So GH, there's no notation, so that means we have to find the measure of the arc from G to H. Again, G to H. That is what we're looking at right there. Fortunately for us, they gave us the angle measure of GKH, which is the same as arc GH. Therefore, it's going to be 122. Now, is this a minor, major, or semicircle? Well, it's a smaller arc, so it's going to be a minor arc. Now, angle GLH. So here we have the notation GLH. So I got to go all the way around using this portion of it. So this is the larger of the arcs, so therefore it is a major arc. And then we have to figure out what the angle of the measure is. Well, if GKH is 122, we know the angles within a circle add up to 360. So all I have to do is subtract 122 from 360. So 360 minus 122 means angle GKH on the far side is 238 degrees. So if that's 238 degrees, then that means the arc itself is also 238. And then we have to state GLJ. So GLJ starts at G, goes through L, and ends at J. So the orange bit here. So is that a major, minor, or semicircle? Well, it starts at one endpoint, runs through the center, and ends at the other endpoint on the other side. Therefore, it is a semicircle, which is half of a circle. So half of a circle, 360, divided by 2, or a straight line, 180 degrees. So that would be a measure of 180. So again, interior angles and arcs are going to be the same measure. So we just have to figure out what angle measures we're dealing with and apply it to the arcs on the outside of the circle. Now we could also have what's known as congruent arcs. Again, congruent means they're exactly the same measure, same shape, same size, everything. They are arcs in the same or congruent circles that have the same measure. So here we have circle L with all these points on the outside. In words, the definition is in the same circle in congruent circles, two minor arcs are congruent if and only if their central angles are congruent. So if we take a look at circle L here, so we can say if angle 1 is congruent to angle 2, then arc FG is congruent to arc JH. So that again will help us out in figuring things out. So if we are told we have two congruent interior angles here, then we know that the arcs themselves are also congruent. We can apply the measurements that we are given in order to figure out unknown pieces. Now, adjacent arcs are arcs that have exactly one point in common. So the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So what exactly does that look like? So here, let's say we have arc X. We have technically three arcs here. We have arc XY, arc YZ, and arc X to Z. So what this means is that arc XY plus arc YZ equals arc XZ. Basically, it's addition, segment addition, angle addition. We've seen it before in previous units, lessons. It's the same thing when it comes to circle. If I take two parts and add them together, I get the whole. So we can apply this and figure out measurements here in Circle F here. So we are tasked with finding these two measures. We are tasked with finding arcs AED and arc ADB. So first, let's take a look at arc AED. So arc AED is here. So we are told we have an angle measurement of 63 degrees. We have a right angle. For that, all we have to do is add them together. 63 plus 90. And I'm going to get arc AED. And I add them together and I get 153. So that one's pretty straightforward, simple. I just add the angle measurements that comprise arc AED and we get a straightforward answer. Arc ADB, we have to do a little bit more. So arc ADB is going to be starting again at A, running through D and going through to B. So we have to figure that out. Now, we know we have to apply what we know a little bit here. So we have angle 63 and 90, so we know this part's 153. Now, how are we supposed to figure out the rest of it? Well, if I take a look at BE, BE is a diameter, and it's a semicircle. And we know semicircles make up 180 degrees. So if EFD is 90, I have to find the remaining piece from BFD. So I know that if I were to add angle BFD and EFD, I'm going to get 180 degrees. So that's the first thing I have to do. I have to find the angle here. So being a straight line, I've already got 90 degrees, meaning this part is also going to be 90 degrees. 90, 90 makes 180. So what I do now is I add my three angles, 90, 90, and 63. So 90, 90 makes 180 plus the 63 degree angle, and that's going to give me arc ADB. Add them together, I get 243, and that's arc ADB. So we had to do a little bit in order to figure out the missing angle, add them together, and I get interior angle of 243 degrees. And again, interior angle is going to be the same measure as the arc we are trying to find. So arc ADB is also going to be 243. So basically, that is your basic information, beginner information when it comes to figuring out angle measurements, arc measurements, and arc segment addition.